Welcome back, everybody, to another deep dive. Today, we're tackling AI creativity and specifically how it generates images.
Yeah, it's a really fascinating area, especially with these convolutional diffusion models.
Right, these models that start with what looks like just digital noise and somehow end up creating these really incredible works of art.
Yeah, it's pretty wild. It's kind of like if you think about an artist working in reverse.
Right.
Like they start with a finished sculpture and then they chip away at it until it becomes like a formless block.
Yeah.
Diffusion models do something similar but digitally.
Okay.
So they'll take an image, add noise until it's completely unrecognizable, and then train an AI to reverse that whole process.
So the AI learns how to kind of denoise the image.
Right.
But wouldn't that just create a copy of the original image that it was trained on? Yeah. Like, where does the actual creativity come in?
Yeah, that's the big question, right? If it was just a perfect reversal, then yeah, we would just expect replicas.
Right.
But the key here is a concept called the score function. And you can think about this as kind of like a map that guides the AI through all that noise and nudges it towards an image that's coherent.
So it's not just blindly reversing the noise. There's actually a guide. There's some logic that's shaping the output.
Exactly.
But how does that logic lead to something new, something creative?
Well, that's where things get really interesting. So theoretically, an ideal score machine, and this is like an AI that perfectly learns the score function that would just spit out copies. No creativity whatsoever.
So perfect learning is actually like the enemy of creativity in this case.
Yeah, precisely. The real secret sauce lies in the limitations of these models.
Okay.
Specifically two concepts, locality and equivariance.
Okay. Limitations being the key to creativity. That sounds a little counterintuitive. So let's unpack that. What is locality all about?
So think of it like the AI is wearing blinders. Because instead of seeing the entire image all at once, it can only see tiny little patches at a time. It's kind of like if you were looking at a painting, but you could only focus on individual brushstrokes and not the whole thing at once.
Gotcha.
That's locality.
So it's making these decisions based on these really small, localized bits of information.
Exactly.
Does that mean that each patch is generated independently?
Not exactly. That's where equivariance comes in.
Okay.
So equivariance basically means that the model can't tell where in the original image a patch came from.
Oh.
So imagine you take a jigsaw puzzle.
Right.
And you just like shuffle all the pieces.
Yeah.
That's essentially what equivariance is doing.
Oh, so the AI knows what the pieces look like.
Right.
But it doesn't know where they fit in the original picture.
Exactly.
So it has that like improvise,
Yeah.
create new arrangements based on those shuffled pieces.
Exactly. And it's this combination of limited vision and then shuffled pieces that creates this incredible opportunity for novelty.
Yeah.
The model can't just copy what it's seen before. It has to recombine these patches in new ways. And that's where the creative spark really starts to happen.
So by combining these limitations, locality and equivariance, the model's almost like forced to be creative.
Right.
This is amazing. So to understand this process a little bit better, we have to introduce the equivariant local score machine, or as they call it, the ELS machine.
Right.
Okay, so this theoretical model combines both locality and equivariance.
Yeah.
What makes the ELS machine so special?
So it's not just like a vague idea. It's been analytically derived.
Okay.
Like we actually have equations that can describe how it behaves.
Wow.
So it's not like a black box. We can actually look under the hood and see how this creative process is working.
We can see the gears turning.
Yeah.
So how does the ELS machine actually generate images? Like, does it actually make something new?
So think of it like you're assembling a mosaic or a quilt.
Okay.
The ELS machine will scan its training data for patches that match the ones that it's currently working on. But here's the thing. Because of equivariance, that matching patch could come from anywhere in the entire data set.
Whoa, so it's not just copying whole images. It's like a collage artist grabbing bits and pieces from different sources and stitching them together in new ways.
Exactly. And even though each patch might resemble something from the training data, the overall composition can be totally novel.
Wow.
So this is how the ELS machine demonstrates the power of what we call combinatorial creativity.
This is really incredible.
Yeah.
We're starting to see how AI can be creative, not just mimicking, but actually generating new things. But this is all theoretical, right? Does this ELS machine actually hold up against, actual trained AI models?
That's the big question, right? And the researchers tackled this head on. They compared the ELS machine's predictions to the output of real-world AI models that were trained on the same data sets.
So they threw this theoretical model into the ring with the heavyweights. What happened? Did it actually hold its own?
You're going to be amazed. So the ELS machine's predictions were incredibly accurate.
Wow.
They closely matched the output of trained models like ResNets and UNets with R-squared values around 0.9 across all these different data sets.
So this theory is not just some abstract idea, it's really capturing how these AI systems are working.
Yeah, it's really exciting.
But what about those weird quirks we sometimes see in these AI-generated images?
Yeah.
Like people with extra fingers or objects merging in these bizarre ways. Can the ELS machine explain that too?
Yeah, that's the beauty of this theory. It actually explains those quirks as well. So towards the end of the image generation process, the AI's window of attention gets incredibly small.
So it's hyper-focused on these tiny details, and it's kind of lost the bigger picture.
Exactly. And so what happens is different parts of the image end up being generated almost independently with very little context.
Interesting.
And so that's what leads to those inconsistencies, those little anatomical anomalies that we sometimes see that make us chuckle.
Yeah, it's like that old saying, can't see the forest for the trees.
Right.
But in this case, it's more like, can't see the hand for the fingers.
Exactly.
Fascinating. But this makes me wonder about those more advanced AI models, the ones that use attention. We've been talking about how the ELS machine has this limited field of view.
Right.
But attention seems to give the AI a much wider perspective. So does that change things completely?
That's a great question. So you can think of attention like giving the AI a pair of glasses.
Okay.
It allows it to see beyond just those small patches and consider the relationships between distant parts of the image.
So instead of just assembling these localized puzzle pieces, it can actually step back and see the whole picture.
Exactly. And that allows it to make more informed decisions, taking into account things like the composition, the symmetry, the overall semantic meaning.
So it's adding a layer of intelligence.
Right.
A more global understanding on top of that patch-based approach.
Exactly.
It's no longer just matching the pieces. It's understanding how they fit together in a meaningful way.
Right.
So does attention completely invalidate the insights we've gained from the ELS machine?
So that's the question, right? Does the ELS machine's focus on locality become irrelevant now that we have attention?
Right, if the AI can see the whole picture now.
So the researchers wanted to figure this out. So they took the ELS machine and they put it up against a UNet model, which is a really powerful AI that uses attention.
Yeah.
They fed both models the same input noise, and then they compared the outputs.
Okay, so we've got our local patch-loving ELS machine going up against this attention-powered UNet that can see the big picture.
Right.
Who won? Did attention just blow the ELS machine out of the water?
Well, the results are pretty surprising. So while the attention model did produce more semantically coherent images, the ELS machine still showed a significant correlation with its output.
Wow, so even though attention can see the whole image, the ELS machine's predictions are still relevant.
Yeah, it's remarkable, isn't it? And what the researchers found was that the attention model's outputs actually kind of fell into these three distinct categories.
Okay.
So in some cases, the attention model seemed to get stuck in a creative rut, and it ended up producing an image that strongly resembled the ELS machine's output, even though it was still pretty jumbled.
So even with attention, it still sometimes falls back on that patch-based approach.
It seems that way. Then there were other cases where attention clearly took the lead, and it generated a semantically sound image that looked nothing like the ELS machine's prediction.
So in those instances, attention is really flexing its muscles and moving beyond those local constraints.
Exactly, creating something truly unique. But here's where it gets really fascinating. The third category was where the attention model created a coherent, meaningful image, but it still bore a strong resemblance to the ELS machine's less coherent output.
That's interesting. So it almost sounds like attention is building upon the foundation that was laid by the ELS machine.
Yeah.
Instead of replacing it completely, it's refining it.
That's a great way to put it. Think of it this way. The ELS machine, with its patch-based approach, might be creating a rough draft, or like a sketch, and then attention comes along like a skilled artist, and it refines those rough shapes. It smooths out the inconsistencies and adds those final touches that bring the whole image together.
So it's like the ELS machine lays down the mosaic tiles, and then attention comes along to grout them and create a smooth, seamless picture.
I love that analogy.
A collaboration.
Yeah. And this suggests that attention isn't starting from scratch. It might be taking the ELS machine's output and sculpting it into something that's more semantically coherent, something that makes sense to us humans.
So even with the power of attention, those fundamental principles of locality and equivariance are still playing a vital role in shaping AI creativity.
Yeah, it's really amazing.
We're actually starting to understand the creative engine that powers these AI systems. It's not magic, it's this beautiful blend of constraints and these clever algorithms that are weaving together these patches of memory into something new and unexpected.
And it really raises a profound question. What does all of this mean for the nature of creativity itself?
Right.
Both in AI and in humans.
Yeah, that's the big question, right? Is AI truly creative, or is it just this master mimic that's rearranging bits and pieces that it's seen before?
Yeah, and that's what we're going to tackle head on in part 3.
Welcome back to the deep dive.
Yeah.
So we've been on this journey exploring the inner workings of AI creativity.
Yeah.
From those tiny little patches of locality to that expansive view of attention. But now the big question, what does this all tell us about creativity itself? Like, is AI truly creative, or is it just this super sophisticated mimic that's just really good at rearranging what it's learned?
That's the question that people have been debating for centuries, even before AI came along.
Yeah.
What's so fascinating is that this research gives us an actual framework for analyzing that creative process, both in AI and in humans.
So instead of just asking, is AI creative?
Right.
We can actually look at the mechanisms at play and say, okay, how does AI's approach to creativity with these patchworks and algorithms?
Yeah.
How does that compare to our own human processes?
I mean, human creativity is such a complex thing. You know, it draws on our experiences, our emotions, cultural influences.
Yeah.
Probably a whole bunch of stuff that we don't even understand yet.
Right. Like there's this idea that true creativity requires a spark.
Yeah.
This leap beyond what's known, something that can't just be reduced to algorithms or combinations of existing elements.
Right. That unexplainable thing that makes a creative work feel truly original.
Yeah. And this is where things get really interesting, because the ELS machine, with that focus on mixing and matching local patches, it kind of suggests that maybe AI creativity is just this really sophisticated form of rearrangement.
Right.
But then we saw how attention can take those patchworks and refine them, create something that feels more intentional, more semantically coherent.
Yeah.
So does that mean that attention is the key? Is that where the spark comes in? That elevates AI creativity beyond just simple combination?
I mean, it's definitely a possibility because attention allows the model to grasp those higher level relationships to make connections that might not be apparent at that local level.
So it's like the difference between just copying letters and actually understanding the meaning of a sentence.
Yeah.
You need that broader context to create something truly meaningful.
Exactly. And this brings us to, I think, a really important point. Maybe we're thinking about AI creativity too narrowly. Maybe it's not about finding a single spark, but understanding this interplay between all these different mechanisms, from those local patchworks to the global understanding that attention gives us.
So AI creativity, at least in these diffusion models, could be more like a spectrum.
Yeah.
On one end, you've got the ELS machine showing us the power of combinatorial creativity through those localized patches.
Right.
But then attention adds this whole other layer.
Yeah.
It weaves those patches together into something more meaningful, something that's more aligned with our own human sense of what creativity should be.
It's a beautiful way to put it. And it reminds us that we're still so early in our understanding of both AI and human creativity.
Yeah.
There's so much we don't know.
Yeah, absolutely. It's fascinating how studying AI can actually give us new perspectives on ourselves.
Yeah.
You know, it makes us re-examine our own assumptions about what creativity is and how it arises.
Right.
I mean, does this patch-based approach, even with attention, fully capture human creativity?
Right.
Or are there these fundamental differences in how we approach the world and how we generate these new ideas?
Yeah, those are questions that we're going to continue grappling with for a long time.
Yeah.
This research doesn't give us all the answers.
Right.
But it opens up this whole new set of questions, a new way of thinking about creativity itself.
Yeah.
And that's what makes this field so exciting.
Absolutely. So this deep dive has given us a powerful new lens to view this creative potential of AI.
I think so.
And who knows, maybe it's even given us a little glimpse into the mysteries of our own creative minds. It's a topic that's going to keep us all thinking and debating for years to come.
Yeah, definitely.
Well, for anyone who wants to go deeper into these ideas,
yeah,
we definitely encourage you to check out the original research paper.
Yeah, it's a great example of how theoretical and empirical work can come together to shed light on the inner workings of these really amazing AI systems.
You can find links to all the source material in our show notes. And as always, thank you so much for joining us on this deep dive.
Yeah, thanks for listening.
We'll see you next time for another fascinating exploration into the world of knowledge.